In this question, we have a sample of gas in a rigid container. It's initially at a pressure of 1.48 atm and a temperature of 299 Kelvin. The temperature of the gas inside the container decreases to 239 Kelvin. We're told the volume and number of moles of gas remain constant, and we're looking to find the final pressure of the gas. So we're given the initial pressure and temperature. So I'm going to label them P1 and T1, one showing initial. And then we're told the final temperature, T2. We're looking to find the final pressure, which is P2. So let's go ahead and fill in what we already know. Our initial pressure is 1.48 atm. Our initial temperature is 299 Kelvin. Our temperature has to be in Kelvin for this equation. So that's great. We don't need to do a conversion because we're given the temperature in Kelvin already. Our final temperature is 239 Kelvin. Okay, we're looking to find the final pressure. So let's go to the reference sheet to find an equation. Here's our equation with changing pressure and temperature. Gay-Lussac's law. It has constant volume and number of moles. So our equation is P1 over T1 equals P2 over T2. So let's write that down. P1 over T1 equals P2 over T2. So this is another equation that is in ratio. So P over T stays constant throughout the situation. So if P increases, T's got to also increase so that the ratio stays the same. Similarly, if P decreases, T's also got to decrease so that the ratio remains the same. In this question, our temperature started at 299 Kelvin and ends at 239 Kelvin. It's decreasing. So we're going to expect our pressure also to decrease. So our final pressure should be less than 1.48 atm. Okay, so let's rearrange our equation for P2, the final pressure. I'm going to multiply by T2 on both sides because that's going to cancel out T2, leaving P2 on its own. So that gives us P2 equals P1 times T2 divided by T1. We can put our numbers in. P1 is 1.48 multiplied by T2, which is 239 Kelvin, divided by T1, which is 299 Kelvin. If we put that in our calculator, we get 1.18 atm as our temperature. And indeed, that's less than our initial pressure, 1.48, which matches up with what we expected to happen. So let's fill that in now. We've got 1.18 atm, and that's correct. Awesome. So we found our final pressure. So again, just to remind you, temperature has to be in Kelvin for this type of calculation using this equation. So if you're given the temperature in degrees C, make sure you convert to Kelvin before putting them into your work table and before putting them into your equation.